Hello. Today is a fine day to lose like 50 or 100 rating points. So we are participating in Codeforces Global Round 26. Yeah. A lot of duels today. So keep tuned. Range is the maximum value minus the minimum value. Okay. A is sorted. And we need to make the range of the red elements not equal to the range of the blue elements. Well, let's just make, so if all elements are equal, then we cannot do it. Otherwise, we can do it. Okay, so we just need to print, yeah, easier problem. VIAN read A, and what do we need to print? Yes or no, okay. So, sorry. Not a good moment for my camera to lag. So we need to ans, yeah, VB-ans is find ans of A. So if ans empty, print no, else yes, and here we print this. Great. So now we only need to make this, and here we check. So if a.front equals a.back, we return nothing. Else we say VB ans of size a.size and a1 stream return ans. And that should work. Okay, let's copy. Let's copy. What's wrong with you? Ah, because it was last time it was an interactive problem and I removed this for some reason. Okay. Yes, BRBB. Yes, BBRB. No, yes. Yes, yes, yes. Let's go. We need to submit this. Why judgment failed? For some reason, judgment failed. Why is judgment failed? What's wrong? I'm getting judgment failed for some reason. Okay, the contest is already messed up. Maybe something's wrong with my library. However, I really don't know what's wrong with it. So basically, it's very bad. It's only for me, yeah. Oh my god. So probably I'll have to use some smaller file. Okay, let's try with some smaller file. I don't know. This is very bad. This is extremely bad. Let's probably it might be my pragmas, but I don't know. At least it could say compile error or something like this. Yeah. Why? No. Excellent. Just excellent. Okay, let's remove it for now. Let's define on PC and on PC files. What else do I need? I need minimum. I don't define files, only define on PC files. Yeah. Okay. So does it work now? Let's try again. So now it's light test and source. Okay, so something's wrong with my template for some reason. Wrong answer on pretest 1. I didn't print anything. Why? I don't want to define my own PC. Yeah, that's really bad. Okay. It's the first time that my library has this. That my template says this. So I'm really not happy about that. But what do you do? Problem B. Digit is large, it's between 5 and 9. Okay. Actually, maybe it's just the first digit. So if first digit is 1, then it can. But if first digit is not 1, then it cannot. Yeah, so if first digit is 1... Okay, if it's 1 and a lot of 9s, it is also impossible. Yeah? It's 1 and a lot of 9s, then probably it's impossible. Yeah, I think it's just 1 and a lot of 9s. I mean, so what do? I need to read... string s, read it and just print find answers yes or no. Great. Find answers bool. Okay, so we need to check. So is it true that a0 is 1 and a is not equal to 1 plus a lot of 9s? Okay, it cannot be also very small. For example, 100. 100 is incorrect, yeah? You cannot do it with 100. Okay, it cannot be too small. It should be at least a lot of 1s and 0. Yeah, so I think it should be like between this number, which is this, and between this number, which is this. Yeah, so the first digit should be definitely 1, and it should be at least this and at most this. Okay, so let's do it. So first digit should be definitely 1. And it should not be... So let's do it separately. So if a0 is not 1, then return false. If a is equal to 1 plus a lot of 9s, then we also return false. Otherwise, we need to return to check if it is at least this number. And how do we do that? We need to find the first digit, which is not 1. And we say that if a not 1 is not 1, we break. Okay, so what? Okay. So if not 1 is at least a dot size minus 1, this means that we return true. Good. So if not 1 is if a not 1 we just return that a not 1 is greater than 1 basically. Okay, let's test that. So first of all, I want these tests. Okay, let's make it 20, for example. And I want some other tests, like 100. This number, this number, this number, this number. Okay. This is like 16. Let's see. Yes, no, yes, yes. No, yes, no, yes. Yes, no, no. Oh, 11th. 11th test is wrong. So what is there in 11th test? 119? 119 is no. The last digit cannot be 9 anyway. So the last digit cannot be 9. Wow, the last digit really cannot be 9. Is it the only constraint? Can I get any number between this and this, which does not end with 9? Can I have 0 somewhere in the middle? And I actually cannot have zeros, maybe. I cannot have zeros. Probably I cannot have zeros. Because if I have 0 and I have here 2 digits, then it's definitely 5 and 5. But if here I also had 2 big digits, then there should be a carry. So I only can have last 0. Oh my god. So, okay, if a back is 9, then return false. Okay, this can be removed. Let's go through all of them. So if AI is 0, we return false. So no zeros except the last digit. Yeah, no zeros except the last digit sounds like a legit rule. Probably yes. So, and since I have no zeros, then this check can be removed. And I simply return true. So only this should change to no. Okay, the last 5 are no, no, yes, yes, yes. No, no, yes, yes, yes. Okay, let's submit that. Oh, I'm so slow. This is very bad. Ah, they changed something. Can I already use my template? Because I don't know. The contest was ruined for me a bit. Because you see what's happening now. Okay, we have a number C. We go through our array and either we add a number, a current number of our array, and probably, if we want, we replace it with absolute value. We want to find the maximum final value of C after the procedure described. Okay, assume that at some point we want to maximize our number. And then if it's this operation, we want to maximize this number, and if it's this operation, we probably want to minimize our number. Okay, so now the question is, we want to minimize our number. Then here we want to also minimize it, and here we probably want to maximize it. So after each operation, we want to know the maximum and the minimum possible values. That's it. Let's do it. So we need to read n and array. What's the difference? You may want to read both versions. The number of unique procedures that result in C equals K. Let's think about this. Okay, I don't want to think about this right now. Let's just do it for now. So we find we just want to print the number, yeah? The number will be long. We say we have file minimum, which is 0, maximum, which is 0, and we say that okay, when we want to maximize, we never want. Okay, so R is simply when we want to maximize. When we want to maximize, we simply take this. So we always, when we want to minimize, we take this, and when we want to maximize, we take this. So R is simply absolute value is maximum of two absolute values. Can I use abs for long? Yeah, I can. Yeah. Absolute value of L plus I and absolute value of R plus I. And L is simply L is plus simply I. Yeah? And then I need to return R. I think so. 12, 256, 1, 8, 16. Something wrong here. What? Ah. 624. Okay, in first test it's because the tests are different, aren't they? 624, 64 billion 22. Okay. I believe in this solution. Okay, problem C2. So how many ways of getting this value? Okay, so the question is, can you, so if your current value is strictly between minimum and maximum, can you get maximum? Yes, so I claim that if you want, so this is minimum and maximum value on ith step, and this is maximum and minimum value on I plus first step. So I claim that actually you can only get to these points from these points. Let's somehow prove that. For example, if we use operation C plus AI. Yeah? So if you want to get here, like this, you probably needed to start here, because if you start here, then you will be inside this segment. The same thing here, I think. Okay, what about the absolute value? I think it's... Is it same? No, it's not the same, probably. Yeah, for example, if... Ah, no, when you want to get... Okay, the first several steps, minimum and maximum are equal, and you cannot do anything with that. So if they're equal, then you simply do what you can. However, at some moment they are different, and the moment they are different, you actually... So again, you make the operation AI plus C modulus. Oh my god, can you get minimum with that? Can you get a minimum? So if you can get maximum, you can only get maximum with... So actually what you're doing, you have a segment, and you do two operations. First of all, you shift it left to right. And secondly, if you have somewhere 0 and you have somewhere segment, and then you can reflect it to the right. Yeah, absolute value is just reflecting to the right. Yeah, so if you know how many ways to get this number or this number, then after the shift you also know the number of ways to get this number or this number. And then there is the reflection thing. So the reflection thing cannot help you with the minimum. So because if you have only positive numbers, then nothing changed actually. After checking absolute value, you did not change anything. And if you have a negative number, then you cannot reach it with absolute value. Okay, so nothing possible with minimum. What about the maximum? So you have 0. Think. Okay, so you have a segment, and then you can either you can not do anything, or you can take the absolute value. Yeah. So first of all, let this be the answer. Okay. So first of all, if this is already the answer and the minimum is less in absolute value, then you cannot reach it. And so you just multiply by 2 the number of ways to get R. Otherwise, if you have the minimum which is smaller than the maximum, bigger by the absolute value, then you have to apply this operation and you get L. And sometimes it is L plus 2R. Okay, let's try and do it somehow. Okay, so I have int L equals 1 and R equals 1. Okay, so what do we do here? First of all, we say L plus equals I and R plus equals I. Now we need to recalculate how many ways to get minimum and how many ways to get maximum. Okay, so first of all, if L is at least zero, then after the operation modulus, you don't change anything. So you just need to double L and R. If it is L, if L is non-negative. Okay, otherwise L is negative. Okay, we can say continue here. L is negative. Here we return R actually. Okay, L is negative. Also, L and R can be equal. So if L equals R, then we need to say that R is minus R and continue. Yeah, because we don't change L and R, because if you take absolute value, we get R, and if we do not, we get L. Okay. Next case is that they are different. So if absolute value L equals absolute value of R, what do we do? Then we say that R okay, let me do it like this. So if absolute value of R is at least absolute value of L, then R is sum of R and R. Else, the only way I think else actually R is 0. Now if absolute value of L is at least absolute value of R, then we can jump from L. So we say that R is sum of R and L modulo M. Finally, let's think about the L. So the only way to preserve L is to not do anything. So basically L is not changed. Now we need to change R and L. L is not changed and R is simply maximum of absolute value of L and absolute value of R. Great. So this should work. And it indeed does. Okay, I want to check. 12 is already what I wanted, isn't it? Yeah, it is already what I wanted. Okay, so let's submit it. Gosh, why did it happen? You are given a string S of lowercase Latin characters, number of non-empty strings T, which is not A, such that it is possible to partition S into some substrings, such that each substring either equals T or A, and at least one substring equals T. Okay, so first case, if S consists only of A's or S does not. If S consists only of A's, then it should be easy. Because you can only have T consisting of A's, and simply it's just any number of A's from 2 to n. It's easy. So answer is n. Answer is n minus 1, I think. Yeah. So the second case is that S does not consist only of A. In this case, we can remove this query because you definitely have to have at least one substring which equals T. So we only need to solve this thing. So how many strings such that S can be divided into A's and into copies of this string? I don't know. Okay, first of all, if T starts from a non-A character, if T starts from a non-A character, yeah? So assume that T starts from A. Then we can actually erase this A and we can remove it. Because you always can replace the prefix A with just substring A. So let's for now assume that we only consider T's which do not start with A. 0. So this is string S. And we say that T does not start with A. And then we can remove several first A's. And the first character which is not A is the start character of T, actually. Okay, we can always take the... let's say that we fix that we take some characters. Then actually everything after that is fixed. Yeah, because we can do greedily. If we see a character A, we have to erase it. We have to put it like this. And if it is not A, then we have to start this pink string. Hmm. Also, I think we can assume that t does not end with na. Okay, and this is some sort of square root decomposition, probably. Yeah, so we can, yeah, we can multiply it by square root of this number. So we can actually do it with z function simply. Yeah, so let's choose some length, and then we do it greedily. And here we just check that the z function value is at least the length. And if it is, then we jump. Also, we want to fast skip several a's in a row, but it can be easily done. So first of all, we write a function to fast skip a's, and we use c function. Okay, great. But then we need to add several a's to the left and several a's to the right. So we want to calculate the number of points in like this subgraph. Oh my god, this problem is interesting. Okay, let's do what they say. This is strange, but let's do what they say. So I want a z function. I want a z function. Is it really small? Ah, it can be long. Okay. Find ans of s. It's long. If a if it only consists of a, we return n minus 1. Yes, we return n minus 1. Then we need to calculate the z function. Okay, first I want to trim s. I want to remove all a's from the beginning and from the end. So while t dot back is a, we pop back it. Then we reverse it. And also do the same thing. Now we don't have any a's from the beginning and the end. I also want to know this number. So int n1 equals t dot size, and int n2 equals t dot size. int from left equals n minus n1, and int from right equals n1 minus n2. Okay, now we need to do some crazy stuff with z function. Z function of t. And we want to iterate over the length of our substring. So let's do it. So now the length is n2. Good. We also want to write a function that skips a's. Okay. And we want to only skip a's to the right, I guess. Yes, so we only want to skip a's to the right. Skip of size n2 and filled with n2. Okay, so if ti is a, then ti is ti plus 1, else ti equals I. So if we have na, we need to skip it, and if we don't have na, we don't skip it. Good. So we want to calculate the minimum length of segment consisting of a's. Min segment. Initially it is, let's say, minimum segment. Initially it is like what? From left plus from right, I think. So int pointer equals length while pointer is less than n2, and we also say bool. If something is bad, let's say that min segment is negative. Okay, so first of all, we want to skip several a's. We want to skip several a's. We skip pointer minus pointer. We want to say that minimum segment is minimum of minimum segment and skip. Also want to say that p is skip of p. Okay, now we jumped here and we want to check if we can add a string. So we want to check that z function in the point p is at least length. So if it is less length, we have to say that min segment is negative. Else we say that p plus equals length. Okay, after that, if minimum segment is less than 0, we continue. Otherwise, what do we want? We want to find, as I already said, the number of ways to choose a point on a two-dimensional integer plane, which is non-negative, which is at most here, and at most here. It should be simple. Now we want to, so we have an answer, yeah, which we will return in the end. So if mean segment is at most is at least from left plus from right, yeah, then we just return and let's say that we have current ans. Okay, else we want to like remove this triangle, I guess. We want to remove this triangle. So we simply take this square, but we remove this triangle. What is the size of this triangle? I don't know. Okay, let's do it like this. So, but if this is less than this, then... So what do we do? Yeah, there are some other crazy cases. Yeah, let's see. For example, this thing. How can it look like? So initially it looks like this. Okay, so it cannot be greater than this, definitely. So it can look like this. Then it can look like this. So it intersects both sides. But then it can look like this, and then it could look like this. So these are all different, actually. Why is D so nasty already? Did a lot of people solve D? Well, they are really fast. Or I'm too slow, but I don't know how to solve this so fast. Okay, let's swap from left and from right. Somehow. Let's say that I have L and R. Okay, so, okay, let's say I have current ans. Okay, first case is that mean segment is at least R. So it's somewhere here. So it's somewhere here. Then I say that it is L plus 1 times R plus 1 minus something. So if it is exactly sum, I need to subtract 0. If it is one more, I need to subtract 1. So I need to take L plus R minus mean segment. And I need to say that current ans minus equals side times side plus 1 over 2. Good. Else, if mean segment is at most L, then I need to say that current ans is something to do with mean segment. Okay, otherwise it is between L and R, so it's somewhere here. If it's somewhere here, then I have to take... Yeah, so let's see what I have. I have some rectangle. I have something like this as a line. And I want to add two things. This triangle, which has side of L plus 1. So I want to say L plus 1 times L plus 2 over 2. This is this triangle. And also I want to take this rectangle. How can I calculate this rectangle? So here I have L plus 1 points. And here I have L plus 1 points. So I can subtract L plus 1 and I get here. Then I can add 1 and I get the size. So I just need to say min segment minus L times L plus 1. It's a mess. Yeah. Okay, there are a lot of wrong answers. For example, Baba. I say 2, but it says 4. For example, when we have B, I can add A or not add A. Let's see. Let's see. Optimize the way. This is not what I needed. What? How can I skip if I removed all A's? How did it happen? So S is Baba. Okay, let's see how it happened. I cannot, sorry, cannot understand. S is Baba already? Ah, because yeah, we had all A's. P is skip P and it happened to be 3. Why? 3, 3, 3 always. Ah, because I need to take skip here. Skip, 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 skip. Okay, now it's 4, 4, 1, 16, 1, 2, 3, 1. Okay, I also want... Let's make something. Let's make at least something. Okay, so I want to check this function actually. I really want to check this function. So let's say I have a rectangle 3 by 7. I have a rectangle 3 by 7. And I want to make some cutoffs. Okay, 3 by 7. Let's start with this, simply this. $32. Yeah, because it's 4 times 8. Times 8. Okay, now let's do like this. 33. Ah, because if I take this separately, I cannot do much. Okay, 35. Okay, so first of all, there are several answers where I take Bob, and it's always 32. So I need to subtract 32 always. So when I have, let's just make a table. I want to be sure. So mean segment and answer. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So here we have 1, 3, 6, 10. So here we have 10. Then 4 more times, it just adds 4. Then it starts adding less. So it's 29, 31, 32, 32. So this is what I want to see. Oh, let's also add 32 to this array. I want. Okay, never mind. I won't do it. But still. So I want 12 tests. So 8 plus 12 is 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. One, two, three, four, 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 3, 2, 1, 1. Yes, probably it's correct. Also, I don't want to have any sorts of overflows, but it seems that there are not any. I got. So it took me 30 minutes. Let's see. Let's just see. Ormless spent like 10 minutes on this problem. 10 minutes on this problem from Ormless. Exactly. 10 freaking minutes on this problem. Shuffle. 2 hungry red pandas, Oscar Allura, have a tree. They want to perform a shuffle. Funny problem. Funny justification why we need to maximize the number of leaves. Well, actually, I see an issue with this problem. Some issues with this problem. So, what do I want to say? Okay, first things first. Let's say that we don't count the root as a leaf. So the root is never a leaf, except it is the only vertex of the tree. The only vertex. Secondly, let's say that f of t is the maximum number of leaves. Not root leaves. Okay, so how can we do something about that? So we choose a vertex, we remove everything here, we somehow shuffle them, and we reattach them. So f of t is maximum of f of t is 1 if I think f of t is 1 if initially we chose a one vertex tree. Otherwise, we just do something here. Okay. Actually, I want to say that f of t is simply 1 if t equals this tree, or a number of leaves if t is not this tree. So it's just number of leaves, but sometimes 1 if this is this tree. Why is that? Because you can simply first of all, you can do this. You can do at least this, because you can always choose as a root non-leaf vertex, except this tree. So in this tree, you only have leaves. Otherwise, you can choose non-leaf vertex and get the necessary number of leaves. However, here you cannot. So let's say that this is f prime. So I have proved that f of t is at least f prime of t. Now I want to prove that f of t is not greater than f prime of t. We can prove it by induction. So let's assume that we have proved it for all smaller trees. Now we want to prove it for a bigger tree. So we choose a vertex. It's not true because of some complicated reasons. Yeah, so actually it's not true. If we have a long bamboo, we can cut it something like here, and then we here and here, then here and here and here, and we get a perfect binary tree. So we can actually get a perfect binary tree. Is it true that we also always want to take some sort of centroid decomposition? Probably yes, but I don't know. Probably it's not a centroid decomposition, but some other decomposition. Decomposition of maximizing the number of leaves. What else can I do? What else can I say? Actually, I have to say something. Other way to calculate the number of leaves is the following. So I take the root. Yeah, I take the root. Take the root. And I calculate the number of its children. Here we have the number of children. Then I subtract 1. Then I do the same for every internal vertex until the end. Till the end. So actually, the more number of the more the degrees of the internal vertices, the bigger the answer. I don't know. Okay, the other way. Let's just ask ourselves. So we take the tree. We take the tree. We take our tree. Let's just ask ourselves which vertices will become the leaves. First, definitely all the leaves of this tree will be It's a hard problem. All these leaves will be the leaves of a tree. Actually, do we really want to? I'm not sure that we really want to take like centroid. Maybe we can do it not dividing by in equal parts, but by dividing in very different parts. For example, let's take the vertex. Let's take the vertex which has children, which has such children, and let's just cut it out. So we cut it. So all these vertices are guaranteed to be leaves. And then we can do anything we want with this tree. So we can do anything we want with this tree, and we just add the answer here. Is it true that it is just the maximum independent set? Yeah, it's probably just maximum independent set. Wow, it's just maximum independent set. You see? So let's prove two things. That answer is at least independent set, and the answer is at most independent set. So this thing. If we have some independent set in our tree, I can easily make it the answer. Yeah. I just need to choose in random order all vertices which are outside of the independent set. So-called dominating set, I guess. So these are all vertices which I try to choose. So when I cannot do it anymore, it turns out that I simply have all them as internal and all these vertices as leaves. Yeah. Okay, now let's prove that answer is at most independent set. It's also easier. Or not really. Okay, let's first assume that we don't count the root. If we don't count the root, then simply if we have two vertices in our leaves which are connected, let's consider the last time when they are connected. So they are here connected, and then we choose some of these vertices as a root, and the other one is not chosen. And this definitely means that it is not a root. The only problem is that probably we can take a leaf, so a vertex can become a leaf. Let me think. Yeah, there is an example. For example, if we have a path of length 4, then we can choose this vertex. Then we can take this thing and put it here like this, and we have 3 leaves. The root may be considered as a leaf if it has only one child. So what can we do? We can take a leaf, and if its removal does not change the size of the independent set, then we're happy. Okay, so for each subtree, I want to know two things. For each subtree, I want to know two things. First of all, the size of independent set, and secondly, the size of independent set if I must remove one leaf. Okay, that's it. And in the end, I just take the second number plus 1. It's quite easy. So I need to read the tree. Good, so we can have constructed the graph. Then I want to find any non-leaf root. I just don't want to have a mess with some leaves. Are there at least 3 vertices? No, actually there are sometimes 2. Okay, let's print the answer when n is at least 2. So if n is at least 2, then return n. Okay, so now I need to find the maximum size of independent set. Find independent set of G. So I want firstly to find the root of this tree. So int root. So if G root dot size is at least 2, then break. Okay, therefore I found the root. I start in a root. It has no parent. I start in G. I go through G. And I return .y. Find independent set. Parent. Graph. That's it. Okay. So how to do it? How to do it? So first of all, if I have no children, if my vertex has no children, I have to actually need 4 numbers, I guess. So yeah, I need 4 numbers. I need. So don't take root. Can take root. And secondly, the same thing, but don't take root and a leaf, and can take root, don't take a leaf. Okay. So for now, so it's like pair of 2 PIIs. And here we need to return a y and y. So how do we calculate the numbers? So some of them are really easy. For example, if I don't want to take a root, yeah, if I don't want to take the root, then I just can take the roots of all my children. I can take the roots of all my children. So x is just sum of .x is just sum of xy's. Okay, and if I can take the root, it's maximum of xx. If I don't take it, and in the case I take the root, And in that case, I don't take the roots of my children, so it's sum of xx. So it's like maximum of this. And here 1 plus this. Okay, what about this thing? This thing is the same, but I want to not take a leaf at least once. So I want to take the maximum x. So let me say. So xx, yx. Let's say, what is yx? Yx is sum of xy's. So I just don't take the root. Minus minimum plus like maximum of y minus xy. And y is maximum of yx and sum of x-axis minus maximum plus maximum of yx minus xx. Okay, good. So let's call them somehow. Max yx minus xx is small. Maximum yy minus xy is also small. Also, I want to find the sum of xy's, sum of xx. Sum of xx. And that's it. Okay, let's go now. So if 2 equals p, we continue. Otherwise, we say find fees of 2vg. Then we need to say that sxy plus equals sonance dot x dot y, sxx plus equals sonance dot x dot x, max yx minus xx is maximum of this, and sonance dot y dot x minus sonance dot x dot x, and yy minus xy yy minus xy. Good. So if this number is less than minus 1000, then probably something's going wrong. And it indeed does. It means that we are just in a leaf. We're just in a leaf. And since we are in a leaf, we need to return the answer accordingly. So if we don't take the root, or we don't take the leaf, then the answer is 0. If we can take the root, and if we're not if we can take a leaf, then the answer is 1. So the answer is like 0, 1, 0, 0. Okay, otherwise, let's calculate the all for numbers. So first of all, xx is just the sum of xy's. number xy is maximum of xx and 1 plus sum of xx's. Yx is sum of xy's plus maximum plus maximum of yy minus xy. And finally yy is xy, no, yy is maximum is of yx and y plus xx plus maximum of this. And return xx y, yx, y. 4, 3, 5, 6. Okay, I want a line graph. So let's add one more graph where I just have this thing. 3, 4, 3, 2, 4, 5, 2. Okay, this is definitely bad. Let's put this graph in the beginning because this is something I understand quite well. So n is 4. Then I found the root, which turns out to be 1. And I want to find yy. I found sonance, which is 1, 0, 1, 0, 0. Yes. Okay, what about 2, 3? 1, 1, 0, 1. Is it true? So if I have such a tree, they say that it is 1, 1, 0, 1. So I don't take a root, it's definitely 1. Can take root 1. Don't take root and don't take leaf 0, and don't take both as 1. Don't take leaf but can take root as 1. Yes. Yes. The answer should be one more than this, I think. Yeah, because... Yeah, plus 1, I think. Yeah, it's plus 1. 3, 4, 3, 5. But now... Okay, it's fine, actually. Yes, it's fine. Already 30 more minutes, while somebody spends how much time? Okay, 22 minutes, 8 minutes. Funny. It's just funny. Guys like ruffles. They just like ruffles. Measurement failed, блин. Reconstruction. There is a hidden array of length n whose elements are integers between minus n and n, minus m and m. Damn. Not good. We're given an array b of length n and a string s of length n, consisting of p's, s, and question marks. Prefix and suffix. How many ways to replace p's and s's with question marks? Such that there exists an array with elements not exceeding n by absolute value satisfying the constraints. Okay, if at least once we have p and then s, then we have some prefix and then some suffix. In such a case, all such sums should be equal. So first of all, we can check that all such sums are equal. Always p and s complement each other. What? My camera just died or what? Okay, it's better. I think I'm going to shut down. I'm just sleepy because of these problems. I can get some cold air here in the room. Okay, good. So first of all, first things first, I can say that I actually add here a p, which is equal to 0, and here an s, which is also equal to 0. It should be quite easy. Good. Okay, now, so if I have p and s, then the sum should be equal to the sum should be equal to the sum of the whole array. Okay, if we have, let's start with the question. If we have all string, the string is fixed. So can we check it? Can we check if the string is fixed? Can we check if the string is fixed? Well, the next question is, can I just check everything about pairs of two consecutive numbers? What do I need to check about pairs of consecutive numbers? So if I have pp, then all I want is that the difference is at most m. That is what I need. If I have two p's, then the difference must be at most m. Okay, if I have PS, then I want that the sum of such numbers is always equal. All such sums should be equal. Next is SS. Also the difference is at most M. And finally, SP. This is suffix, this is prefix. So I want the difference between this number and this number to be at most M. 2M actually. Okay, is there anything else? I think that no. I think that no. But let's see. Firstly, SS. When I see SS, what does it say about? It says about this character. So left S. When I see PP, it says something about the right P. When I see PS, it doesn't say about anything. When I see about SP, it says that the difference between this and this should be at most should be equal to the sum of these two numbers, actually. The sum of these two numbers. But it is the S to the right of which there is P, and this is S to the right of which there is S. So actually, I believe that they are always different. And so basically, I just need to check everything for the consecutive characters. Okay, that's it. For any consecutive characters. So if the difference between them is at most M, then I can preserve M. And if the difference is if they're PS, then I want the sum to be some constant, and if other way, then the sum should be at most 2M far away from this constant. Okay, with this out of the way, how to solve the problem? Actually, we can solve it in square time. It's good. It's good. Why it's good? Because we can iterate over all possible sums. Yeah, actually, we can iterate over all possible sums. Let's iterate over a number which will be the sum of the whole array. It is definitely in our array since we added this P and S, so we will have to have PS somewhere in the array. Okay, and then we go one by one and check the number of ways to end with an S and to end with a P. Okay. Okay, then let's go. So solve test, we need to read the... What is 10? M. 10 to the 9. 10 to the 9. Okay. Int N and M. Then we read a string. Then we need to read the array. Okay. Finally, we need to print the number of ways, which is just fine done. Number of ways might be big, so this is a must. Good. Yeah, I think I need to remove that function because it's not a good idea for the hacks to have it in my solution. So this should be removed. I just need to rewrite function findAns. Yes. So I need to give here S, V, and M. Well, I also need to check. Okay. Or not okay. Probably I need to check that my sum is at most mn, something like this. But no, I don't need to do it. It will hold automatically. Yeah. So let's go. I need to choose my sum and then I need to calculate the answer. So what do I do here? I need to push back and push front zeros. Okay. Then I need to iterate over, let's say const m is size. I need to choose my sum. Let's somehow store all of this. So unordered map. Let's just take map. Cannot maps. Unordered set. So let's say that I have sum which is vi plus vi plus 1. This is what I'm trying. So if sums dot insert, I cannot insert. So if sums dot count s, then we continue. Otherwise I say that sums dot insert s. Then I want to add something. So I say current ans is 0, and in the end I will say that ans is sum of ans current ans modulo m. Okay, so I need to calculate the current ans. And actually to do that I will have two current answers. Number of ways if my current symbol is, oh yeah, so actually here I also want to do the same thing with s. Oh, here reverse. Oh, I want to constant n equals size. All s dot pushback p. Then I again reverse and add s. Yes. Here seance is sum of seance actually I have seance prefix and seance suffix. Initially seance prefix is 1 and cyan suffix is 0, simply because I start with a P, and in the end I end with an S. So now we want to iterate over all remaining characters. Great. So now I'm here. So let's assume that I already know the number of ways here. So I know the answer when this is P and when this is S. And I want to calculate the number here. So I need to say that I have int new ans P and new ans S. Then I calculate something. Then I want to say that if Sj is P, then nuance S is 0. And if Sj equals sm nuance P equals 0, and then I say seance P is nuance P, seance S is nuance S. Okay, I need to find new answers. So I have 4 combinations. Okay, let's find out about all of them. So first of all, PP. So if the difference now is small, so absolute value of Vj minus Vj minus 1 is at most m, then nuance P is sum of nuance P and seance P. And also about S's, the same about S's. If Vj plus Vj minus 1 turned out to be equal to my sum, then nuance S is added seance P. And if the difference between them is no more than 2m, then vice versa. Okay, that's it. That's it. Let's try to get accepted. Compilation failed. Okay, 102, 114, 1. So here I said 0, but it said 1. Big question. So again, it said 0 while it should have said 1. Something. I think. Yeah, I think we need to do like this. Yes. Yeah, it's fortunate that I noticed it because I could easily. I was misguided by the synthesis. Okay. Let's try to submit it. Good. Good. Or at least not bad. I am already here, you see? I'm top 20 again among my friends. And now I need to fast solve G or H. To resolve G in like... Okay, let's maybe try to solve H. I don't know if it's easy, but some people did it. Rainbow solved it in 52 minutes. Rainbow is not bad at solving hard problems. Probably. Okay, magic trick 2. I just think I don't have chances. I think we need to read both, but we need to really fast choose which of them we like more. Ah, there's a triangle. There is geometry. So we have endpoints on a plane. No 3 are collinear and nor 4 are concyclic. Initially you own towers these and you want to capture all of them. You want to do the following operations. Pick up 2 towers P and Q you own and 1 tower R you don't own, such that the circle through PQR contains all n towers inside it. What if it does not exist? Afterwards, capture all towers in or on triangle PQR, including tower R itself. An attack plan is a series of choices of R using the above operations, after which you capture all and all towers. Well, it's hard, isn't it? I'm not very bad at geometry problems, but what? So first of all, they say that there exists a circle which contains all points. Yeah? Notice that if there is such a circle, then it is probably... There are only 2 of them actually. Yeah, because you either choose... So basically we have 2 towers here. If we start to move it to that way, it stops going through... Oh, sorry. What did I do? Ah, teleported somewhere. So if I move the circle up, then it looks like this. Okay, I cannot move it down because I stop having this point. But if I move it up, I stop having some point at some moment. So okay, there are at most 2 plans. If I choose upper or lower semi half plane. And since there are no 4 concyclic points, I definitely have only 1. So when I have chosen the when I have chosen the half plane, I have only 1 way of continuing. did it? Tourist just solved all problems. Yes? Yeah, tourist solved all problems in 2 hours. Funny. Okay, now we have fixed the half plane and we have a triangle of points. What then? We have a triangle of points and all points lie in this circle. So what then? Actually, it seems that whenever we take a new point, we have to add it to our convex hull. Yeah, I think it's true. Whenever we add a point, we have to add it to our convex hull. So let's prove it somehow. So we have some convex polygon and it is fully filled. Then we need to add one more vertex. Oh my god, it's hard. 200, 100 towers. Again, what do we do? So all points except the convex hull don't matter. So let's assume that we have a convex polygon. We want to firstly check that there is a circle which contains all points through these 2 points. And it should be not hard. Let's assume that we can do it. Okay. So we assume that we can do it. Then we have 2 points, either here or here. Let's fix that we have chosen this point. Then we can as well take this point. Ah, it's some sort of graph, I think. It's some sort of graph. The question is, how many ways are there to capture all points? So the problem is as follows. So we have 100 points. We have 100 points. There is a way, if we have 2 points, to get... Ah, we only get one more. I see, we only get one more. I think Turmax just got tail on this problem. Wrong answer, test 2, okay. Right. Okay, so again. Actually, for each couple of points, there is either 2 or 0 points which we can take. We need to somehow understand some properties, basic properties. So for example, if we have 2 points and we have these 2 points, is it true that we never want to take these 2 points? Actually, is it true that we never can accommodate? So is it true that if we have 2 intersecting segments, then either these 2 cannot accommodate both of them, or these 2 cannot accommodate both of them? So let's try. So assume that there is a circle like this. Is it true that there is no circle like this? Probably yes. And vice versa. You cannot have something like this, and you cannot have circle like this and circle like this. This is impossible. So basically, for any 2 intersecting segments, one of them is better than the other. And since it's true, well, it's not a bad problem, but it's hard. I have real chances of not solving it, which I will not like. Okay. Okay, the question is it true that I always want to choose at least one of these 2 points? So at least one of these 2 points should always be taken in any operation. So suppose not. Suppose not. So I have these 2 points, A and B, and I did not take any of them. So I have taken 2 other points, C and D. So there are 2 cases. First of all, if this segment is looks like this, C and D looks like this, then I know that there is a circle like this which contains both C and D. This means that there cannot be a circle through C and D which contains A and B. Yes, probably yes. Okay, this means that we understand what it means. It means that actually segment CD should be outside. But still, let's increase, let's like consider this circle and let's increase it until it first touches some of the points C and D. For example, it looks like this. Okay, what can we say then? Well, I don't know, because now it's quite hard to say. If there is a circle which contains all points, definitely. Not definitely, but probably there is a circle like this. Oh. Actually, is it true that if I have a circle which contains all points and it contains... I need some examples. I cannot think like this. It's impossible. For example, if I have something like this, I probably can have a lot of circles like this, like this. Ah, no, I cannot. So basically, if we have two circles which contain all points, they look like this, okay? This definitely means that all points lie here, in this area. They can look, for example, like this. Not much time left. Yeah. So, can I do... Can I say that this is something like graph on pairs of points, or not? So let's say that I have 2 points and 2 other points. Hmm. So okay, this is definitely possible that I have. I don't know. I want to say that I have 2 points here and I have 2 points here. But if I want to capture something new, so there are 2 cases. If I want to capture something here, yeah, so I need a circle like this. Okay, a circle like this. Let's say that there is also a circle like this, which contains all points. Can I also capture this point? Probably not. Probably I will capture something else. So is it possible that I capture something else? Let's draw it a bit more normally. So I have 2 points A and B. I have points E and F. And this circle, like this, I have... Can I also have a circle like this? Which contains all these points? Something like this. Is it possible? So basically, what's the question? Can I have a circle and another circle which contains both C and D? Contains at least 1 point here as well. But also contains at least something inside. Or is it impossible? So, can I have a circle which contains A and B and this point, but still passes through something inside of this part? No, I think no. Because let's say that it intersects this line in these 2 points, then this angle should be equal to this angle. But this angle seems to be inside that. Yeah, so if this is impossible, what can we derive from that? We can definitely say that what? That I cannot capture it's not possible that I can capture something here, and as well I cannot capture anything here. What about this middle part? Probably also no. So what's the question? The question is, can I have a circle like this? So what can I have or not have? Can I have a circle like this? Good. I think we need to make some hypotheses which will not be able to prove. You know what I think? I think there should be something Hamiltonian about that. So, what do I want to say? Let's take some circle, for example, like this. What can I do with it? I can start moving it down so that it looks more like this. Okay, now it is fixed like this, but then I can also move it in some direction. So I have something like a graph. Oh. Well, it's a funny problem, but no way I can solve it. No way. Actually, I am not even true. I'm not even sure now that it is enough to capture all vertices, because you also need to capture everything inside. You also need to capture everything inside. Well, will it happen automatically? It actually will not happen automatically. Yeah, for example, if you have some polygon, you want to add a new vertex. What if you add something like this? What if you add something like this? Will it never happen? Because it seems like it is possible that you have something like this, or no? Maybe we can do an inversion. So what if we do an inversion in this point? Then okay, again, we want to capture a point. We want to capture a point at some moment. Let's make an inversion in center with it. What do we want? We want some circle which passes through it and contains all vertices of the polygon. If we make an inversion, then now we have several points, I don't know, they look like this probably. This is the center. And we want to cut off all these points from this one. I think this is what we want to do. But the question is, I have several points. I have another point, and I want to cut it from all the others. Can I? And I can do it with some side, but can there be many sides like this? And yes, there can be many sides like this. For example, in this case, all these lines, they cut the polygon from the point. So there are really many ways to do it. I hate this problem already. Well, it's already a failure. I cannot solve problem H. I don't feel like I'm doing it. So problem G maybe. By permutation, we can take a continuous subarray of length k and remove it from P and insert it back into any position. And he wants to choose the maximum value of k that he can sort his permutation. Actually, it looks like we just can make any element jump P positions in any direction. Yes. Okay, let's try to do it one by one. I don't know. So let's take the minimum. We want to put the minimum in the beginning. And we maybe can do it. Yes, we can do it if k is at least, if k is not equal to n, then we can do it. Okay, now the minimum is in the first position, but now we don't know what to do with the second position, with the second minimum. At some moment, we will have a problem that we have to somehow touch the minimum elements. Yeah, so for example, we have actually I can say like this. So the operation is we can take any no. Is it true that the problem is monotonic? The problem is probably monotonic. Or not. So let's say, for example, 1, 2, 3, 4, 5. Yeah, I can take 3 elements like this and put it in the end. I shifted one position. 4, 1, 2, 3, 5. Now if I no, let's the vice versa. I say that I put 5 in the beginning. Now I can make an operations of 3 and I want to sort it. What can I do with an operation of 3? So first of all, I can make a cyclic shift of the array. Actually, okay, let's say about 6, for example. 6, 1, 2, 3, 4, 5. And I have an operation of size 4. Can I do something? So if I only make cyclic shifts, then the cyclic shifts will always be even, which is a problem. Okay, I think there is something with the parity of this permutation. Yeah, because it is always some combination of cycles of size of some size. Yeah, so if basically if k is even, then I only can do some even permutations, not odd. Can I make a permutation of 2 transposition if I have... I got this. Can I make a transposition if I have, for example, even an odd number? I would like to be sure that I can. I could. Okay, for example, 1, 2, 3, 4, 5, and I have a size of 3. What can I do? And say 4, 1, 2, 3, 5. Then I... Okay, 5, 4. I want to swap 4 and 5. How can I do it? How could I do it? Let's say 1, 2, 1, 4, 2, 3, 5. Then probably Okay, so I have some odd block. I have some block of size n actually, of length n. What can I do? Time. Okay, let's do some basic stuff. So first of all, let's check that it is cyclic. So if pi is sum of p0 and I modulo n, then it is not cyclic. And if it is cyclic, then if p0 is 0, then return n. Otherwise, we need to return n minus 1 and something. So what do we need to do? Otherwise, we need to return n minus 1 and a vector which consists of p0 operations of taking from 0 and putting it on 1. Okay, good. So now our array is not a cyclic shift. So let's probably learn how to make such a swap of 1, 2, 3. Oh my god, I don't have enough time, but I feel like I know what to do. So first of all, I need to learn how to make a cyclic shift of 3 consecutive elements. And I need to learn how to make at least one transposition, maybe. Okay, so let's learn how to do it. Let's probably take 1, 2, 3. And then no, actually it didn't work like this. It should be 3 and here 2. Now let's take this block. And in the end we want something like 2, 3, 1. Okay, let's fix that. That I just want to have n minus 2, something like this. I want n minus 2. I want this size of block. Can I do anything at all with this operation? Probably I can something to do something. So I can put 2 here. Then I can put 1 here. Or can't I? Can I put 1 here? Yeah, I can put 1 here. Well, I can actually... What can I do? Nothing crazy. Now I can kinda do it in cube time or in fourth time, but not in squared. And squared is too few for me. So I kind of want to make sort with the operation of size n minus 2 or n minus 3. Let's do it one by one, for example. So assume that I already have a 1 to etc. I, and I want to put I plus 1 here. Or here. So if I do something like this, I mess up the structure, of course. I see what I can do. I can I can put I plus 1 in the end. I can put I plus 1 in the end. Then I can move this here. And then I have 1. Actually, it's always possible. So what can I do? Let's say that I want the suffix to be 1 to etc. I something. Let's say that I want now a number I plus 2 to be put here. Do that, I just cyclically shift it to the left. Hmm. So the question is, where is I plus 2? So if I plus 2 is among the last n minus 2 elements, then I win. Because I simply make cyclic shifts of these n minus 1 elements. Actually, if it's among n minus 1 elements, I win because I can make a cyclic shift on these elements. And I end up with 1 to etc. I plus 1 being somewhere here, and here I have I plus 2. And then I can cyclically shift these elements and put it back here. Yeah, the problem with that is that at some moment this element I plus 2 is the first element of the array. And I'm not sure what to do with it. I can ignore it for now, probably. But I cannot ignore it all the times. Okay, let's agree that we will not solve this problem, which is sad, but what can you do? This was a huge mess. Maybe I can really hack something. Oh, guys, just destroying me. It's sad to see, actually. It's sad to see. Wait, you really don't want to solve like problem C2 in 34 minutes instead of 13, etc., etc., etc. Yeah. Okay, let's have a fast editorial because I'm tired. Management failed. Yeah. Problem A. Okay, so we are given a sorted array. We want to color its element red and blue such that the difference between maximum and the minimum among the red elements is not equal to the same of the blue elements, and there are at least one element of each color. So it's a pretty easy problem. The first thing that you ask yourself, what if I color one element in one color and all the other elements in the other colors? For example, there will be only one blue element, and the red elements will be all except this one. Well, here the range will be 0 by definition. By definition, the range here will be 0. Simply because maximum and minimum are equal to this single element. So the only thing that we want is for range to be greater than 0 here. Now the question arises, how can the range be exactly 0? Range is actually 0 if and only if minimum is equal to maximum, and this is true if and only if all elements are same. So now we have the following problem. We are given an array, sorted. We need to remove one element such that the range, such that not all remaining elements are the same after the removal. So we have n elements. We need to remove one of them such that the rest of them are not same. And so how can they all be the same? If we leave elements a1 and an and we do not remove them, then most probably they will be different. Yeah, for example, if we remove a2, yeah, then we win. Because a1 and an are probably different. So let's say if a1 is not an, then win, because we can remove a2. What if a1 is equal to an? In this case, all numbers are equal because this array is sorted. If in a sorted array you have two equal elements on the first and the last positions, then all elements are same. And in this case, this is a loss. So what you do is you read the array, check this condition. If it is true, you report no. If it is not true, then you print string r, b, r, etc. r. Bad performance. Do you want to be unrated from the route completely? Well, it depends actually on the... It depends on the... It depends on the rating change. So actually it's cheesy that I can choose. Well, to be honest, to be completely honest, so first of all, to be really honest, yes, I was frustrated, but it didn't slow me down very much. It slowed me down quite a bit. But the frustration was There, maybe I was demotivated. I really participated worse than I should have. On the other side, I don't know. I don't think there is much of a reason for me to say that it will be rated. Okay, they skipped my submissions, which is funny. Okay, damn. Let's go on. Sorry for that. Problem B. Large addition. A digit is large if it's between 5 and 9 inclusive. A positive integer is large if all of its digits are large. So can an integer x be sum of two large positive integers with the same number of digits? This is the question. Actually, only now do I understand why they wrote the same number of digits, because otherwise you would be able to do something like 9 plus everything else, which is not good. Or 5 plus everything else. Probably not nice. Okay. Let's just look at what's happening. So we have some number in which all digits are at least 5. And you add another number which is also of digits which are at least 5, and it has the same length. Then you add them up. What do we get? Actually, we get if we add them up, so what can we notice? First of all, we definitely notice that this in each column we will have a carry. Carry is when you add in this way two numbers, when the sum of two digits exceeds 9 and it is at least 10, you cannot write 10 here. So instead of that, you write the sum minus 10, but you add a carry bit here. Not a bit, a carry 1 here. So here the sum will actually be 1 more than what you expected. Good. So first thing that you know is that always there will be a carrier. So for instance, here you will have a carrier. So definitely this digit will be 1. The second thing that you might try is just take the minimum possible numbers and the maximum possible numbers. So what is the minimum possible number, which is the sum of such two numbers? It of some fixed length. To achieve that, you need to just take all 5s. Yeah, because all 5s plus all 5s is the minimum possible sum. Let's sum them up. We get 1, 1, 1, 1, 1, etc. 1, 0. If we do the same thing for 9s, then we get 1, 9, 9, 9, 9, 8. So the number should be between this one and this one. So for instance, this is clear that the first digit should be 1. What else should we check? What else should we check? Well, now you can have a question. Is it true that any number between these two can be achieved? And the answer is no. If you play with, for example, the samples, you can find several examples of it not being enough. Sorry, Codeforces is not running. Properly. Okay, so here definitely we already can say that it is no because it starts with 2. This starts with 1, 1, 9, so already no. Again, no. Yes, no, yes, yes, no. And here we have a number 119. For some reason, 119 is no. But indeed, it is between number 110 and 198. So what's the problem here? Why is it no? Well, actually, if you investigate into it, you see that the last digit cannot be 9. You can never take two digits, which are at least 5, and get here 9. Because actually, since, as I said, we will always have carry once, it should be 19. You cannot have two digits with the sum 19. It's impossible. Therefore, the last digit should not be 9. If it is 9, you immediately say that the answer is no. Is it enough for now? For now? Again, it is not. This is not the only condition to check. Well, when you see all these digits, you see that they are all ones. You might ask yourself, how do I check that this number that I have is at least 111110? Well, it's easy. You just need to find the first non-zero digit somewhere. No, not one digit. And check. If it is 0, then the answer is less than this number. And if it is at least 2, then the answer is at least greater than this number. Okay. So if it is at least 2, then it is big enough. If there is 0, then it is small. So basically it says that you cannot have 0 and before that 0 all ones. Actually, a more strong thing holds that you just cannot have zeros. So all these digits should be non-zero. Let's understand why. So assume that you have a 0 and the 0 is not the last digit. As I already said, you definitely have a carry. So the sum of two digits above it plus the carry u should be 10, because since you always have a carry, it should be 10. So d plus e plus u equals 10. Why do I write u instead of 1? Because if this is the rightmost position, then u is 0. So u is 0 if we are in the rightmost position, and 1 otherwise. Actually, it's better called c, because c for carry. Okay, so as I said, d plus e plus c should be equal to 10, where d and e are two digits where you got 0 in the answer, and c is the carrier that arrived in this radix. Well, notice that d is at least 5 and e is at least 5. So actually d plus e are already at least 10. If you on top of that have c, which is at least 1, then you lose because this will be at least 11. And c will be 1 if we are in an internal, not the rightmost position. So actually you cannot have zeros inside of the number. Only the last digit can be 0. So we have already the following observations. The first digit equals 1. Middle digits are not equal to 0. And the last digit should not be equal to 9. That's it. Actually, this is enough to get the correct answer. So if all these three hold, then you get, then the answer is possible. Let's prove it. So the fourth time I say, since every time you add two digits which are at least let me think. Okay, what I want to say. Let's say that the first number is a1, a2, etc., an. The second number is b1, b2, etc., bn, and you get c1. Let's call it, for example, c0, c1, c2, etc., cn. Okay. You add these two numbers and get this one. I want to prove that such numbers a1, a and b exist to get this one. If we know that c0 is 1, c1 is not 0, c2 is not 0, cn minus 1 is not 0, and cn is 9. Is not 9. So this is what we know. I want to construct such numbers ai and bi. What do I need for that? Actually, all I need is for ai plus bi always be equal to ci plus maybe 10 if there is a carrier. And since there is always a carrier, then ci plus 10. So this is what I need. Oh, not that, sorry. Plus carrier from I minus 1. I plus 1, sorry. So carrier. So if I have AI, BI, and CI, this is carry I plus 1. So AI plus BI plus carry I plus 1 should be equal to CI plus 10. All we need is to find such numbers AI and BI that for which this holds. Okay, let's do it one by one. So let's start with CN. With CN, we just want two digits, AN plus BN, which sum is equal to 10 plus CN. Since CN is not 9, it is from 0 to 8. This means that this number is from 10 to 18. So you need to find two big digits which sum is from 10 to 18. For any number from 10 to 18, there are such two digits. Like 5 plus 5, 5 plus 6, 5 plus 7, etc., 5 plus 9. You get all sums from 10 to 14. And then you can increase gradually the first addend, and you get from 14 to 18. Good. Now the middle digits. So in the middle part, this carry I plus 1 is always 1, because you get to carry from the previous radix. So you get 1 plus AI plus BI should be equal to CI plus 10. So AI plus BI should be equal to CI plus 9. And this time CI is not 0. Well, it's always possible again, because, again, this is any number from 10 to 18, and you can achieve any number from 10 to 18. Why from 10 to 18? Because CI is from 1 to 9 according to this part of the constraints. Sorry, there is my face. Finally, you want this digit to be correct, but it will always be true because these two digits are big, so there is always a carry. There is exactly one carry, so you have one here and one here, so they're equal. So shortly, you need to check these three things. You read a number, you check its first digit, which should be equal to 1, middle digits, so not the first, not the last. The middle digit should be non-zero, the last digit should be not 9. And that's sufficient and necessary. Problem C. Two different versions of this problem. So we are given an array A of length n, and we have a counter C. Not counter, but some accumulator, some number. Then we iterate through the array A. We add number AI to the accumulator, and if we want, we can after that take modulus. So as you see, we always add number AI, but then we either leave it as it is, or we take the modulus, absolute value. So we do it, and we want to maximize the final value. So let's see what's happening. Basically, so let's say that we have some C0, which is 0. Then we applied the first operation and we got C1. Then we applied the second operation and got C2, etc. Cn. So the Cn should be maximized. How can we maximize Cn? Well, how do you just generally approach such problems? The first solution, which works in O of 2 to the power n, is just a recursive one. Always when you have some choice of two options, yeah, so for example, Ci can lead to Ci plus 1 equals Ci plus Ai, or to Ci plus 1 equals Ci plus Ai absolute value. Always when you have a choice, you can just run a recursion. Try this option, take the maximum. Since on each level of recursion you double the number of branches, in total you will have these asymptotics. How can you speed up such a solution? To do that, you need to... So, if you consider it like a tree, yeah? You have ith level, and on the ith level, what is your state? Your state is the value of Ci. So you have several different values of Ci, which are possible. And you somehow transform them into some possible values of Ci plus 1. The key point is not to consider all possible values of Ci. The key point is to understand that some of them are useless. That is, they cannot be useful to reach the maximum. So they can be ignored. If on each level you can only leave a constant number of options, then you will have constant number of transitions on each level. So in total you will have O of n solution. So basically what you do, you have some values of Ci which are now possible. You make all possible transitions from them to Ci plus 1. And then you need to filter out the values which are definitely useless for getting the maximum. And then you repeat. This is your pipeline, if you say. Let's understand which values are useful and which are not. Yeah. So let's say that we have some number Cn, which let's like draw a line, a coordinate axis, and put there all possible Cn's which are possible to get. So there are some numbers, and this is our goal. This is the maximum number. Let's look at the previous values. Yeah, so somehow these values are transformed into these values. Okay, we want to get this one. We're not interested in getting this one or this one or this one or this one. Only the maximum. This is what we want. How can we get the maximum? With some transition. There are two types of transitions. Ci plus, Cn minus 1 plus an, or Cn minus 1 plus an modulus. Let's start with this one. Can it be the maximum? Well, actually, if you apply the first operation, you only want the maximum value of Cn minus 1. If you add an to this number, it cannot be maximum. Because if you increase Cn minus 1 by some number d, the answer will also be increased by d, and that means that this wasn't a maximum. This is bigger number. So when you apply this operation, you only want Cn minus 1 be maximum possible number. So if you're interested in getting maximum possible Cn in one operation of first type, you're only interested in the maximum possible value of Cn minus 1. Okay, now let's look at the second one. The second one is either equal to the first one, yeah, if the absolute value is if the number under the absolute value is positive, then it's same as 1, and you're also only interested in the maximum Cn minus 1. But if it is negative, then you want, if you want to maximize the absolute value, then you want to minimize the number under the absolute value. And in order to minimize it, you want the minimum possible Cn minus 1. So you want the maximum and the minimum Cn minus 1. These are the numbers that you're interested in. Now, you might think, well, we have proved that we are only interested in the maximum and the minimum possible values. That's it. Let's just always maintain the maximum and the minimum possible reached value. And no, this is incorrect. This is still incorrect because, well, you have increased what you want to reach. You have increased what you want to reach. So we're interested in the maximum here. On the nth level, we're only interested in maximum. But on the n-1st level, we are not only interested in maximum. We're also interested in minimum. What if for getting the minimum, we need some intermediate values? And for that intermediate values, we need even more intermediate values. Yeah, so if you want to get the maximum in one step, you're interested in minimum and the maximum. So on the previous step, you want to not only get the maximum of Cn minus 1, but the minimum as well. Now the numbers that you're interested, there are two of them and not one. So you need to check how do you get the minimum possible value of Cn minus 1. So let's look again. So we want to get minimum possible value of some number Ci. Ci is either Ci minus 1 plus Ai or Ci minus 1 plus Ai absolute value. First things first, this is always true. So actually, if you want to minimize your Ci, you only need the upper formula. where you take ci minus first plus ai. Because if you take the lower one, it's actually greater. And if the lower is minimum, then the upper is also minimum. How to minimize this number? You actually need to minimize this number. So to minimize ci, you just need to minimize ci minus 1 and add ai. So actually, minimization problem is really easy. So always minimum possible ci is simply a1 plus a2 plus etc. plus ai. Because you might assume that you never apply this operation to get minimum ci. Well, you can apply sometimes, but you need not. This is the minimum ci. Actually, at each moment we can just calculate the minimum possible ci as this sum, and maximum ci is simply maximum of minimum pi minus 1 plus ai and maximum ci minus 1 plus ai. This is what you can do in linear time. So in each next operation, you just add the next number ai plus 1 here, and here you find this maximum and calculate it. Let's go on. Gosh, when I solved ABC, someone already solved F. Not good. Not good. Okay, problem C2. In problem C2, not only do you need to... you don't need to find the maximum value. However, you need to find the number of unique procedures that result in this maximum value. Okay, you need to find the number of procedures. For that, so as I said, when you need to find minimum or maximum, you're only interested in the minimum and the maximum values on the previous stage. Well, actually, in this problem, a priori, this is not the case. What do I mean by that? Assume that, for example, that you have one more operation, multiply by 0. We have an operation in which we can just multiply our number by 0. Okay? Well, you might say, we're still not interested in these intermediate values. So, because if we take any intermediate value and multiply it by 0, we get 0. But why would we do it with the intermediate value if instead we could do it with this value? So intermediate values are useless because the only thing that we can do with them is multiply them by 0. But we could as well multiply by 0 the minimum or the maximum. So everything that can be done with intermediate values can also be done with the edge values. So we don't need these still. While it is true for the problem of reachability of some number, so of maximization of the result, or for a question, can we reach number which is at least k for some number k? While it is there, definitely useless for that number, for that problems. If you want to calculate the number of ways to do that, then it is incorrect way to do that. You can reach this 0 by multiplying not only this number by 0, but this number by 0 as well. It would be not correct to say that they are useless completely. This here useless for the yes/no question, but they are not useless for the how many ways question, because probably they can participate in some sequence of actions which reaches 0, which reaches the maximum. So we need to additionally check, is it true that these numbers simply cannot be used for getting the maximum. And indeed they cannot. So again, we need to check two things. First of all, we just need to check the following thing. If we take not minimum and not maximum ci minus 1, we cannot get minimum or maximum ci. This is what we want to prove. So it is impossible for intermediate values, which are not minimum or maximum, to increase the number of ways to get the minimum or maximum on the next stage. Let's prove that. Let's start with the maximum. Let's start with the maximum. So we have some maximum ci. Yeah, so this is ci. And we want to get it from ci minus 1. And not from the minimum or from the maximum one. Notice that you only need the operation ci minus 1 modulus with AI, because it is always at least ci minus 1 plus AI. So if you want to maximize your result, you only need this operation. Okay? Okay. Then you want to maximize it. This will be either ci minus 1 plus AI or minus ci minus 1 plus AI. So if you choose this option, then you need the maximum possible ci minus 1. Because if you take not maximum ci minus 1, then it will be less than the maximum possible value. Likewise here, if you want to maximize this, you want the minimum possible ci minus 1. And if you take not the minimum ci minus 1, but something else, this number will not be maximized. Actually, for getting maximum, you only need maximum and minimum. Now let's go on with the minimum. Minimum ci is minimum possible ci minus 1 plus AI. Notice that you again don't need absolute value, because absolute value is greater than not taking the absolute value. Okay. So, as I said, here you don't just have any choice. You cannot take either sum or absolute value of sum, because there is no need to take absolute value if you can take just sum. Again, I'm talking in terms of reachability of some number and not in terms of number of ways. In number of ways, taking absolute value can be useful even in the case of minimum. But nevertheless, in terms of getting the minimum possible value, you just always add AI. And you can see that to minimize this number, you always need to minimize this number, because if you take this greater than the minimum, then this sum will also be greater than minimum. So we have proved that actually the intermediate values should not be used. They should never be used. You should just ignore them at all moments. So now let's do the following. We store 4 things. We store our current minimum number. We store our current maximum number. And also we store number of ways to get minimum, number of ways to get maximum. Okay? Now let's try to maintain it. First of all, we have our segment minimum, maximum. And first of all, we need to add AI. So we have some new segment after that. Now we have a choice. We can either take modulus, or we can just leave this number as it is. And we need to find the number of ways to get minimum and to get maximum. Let's start with the minimum. The minimum will be just L. Yeah, the minimum will be L. Because if you take absolute value, it does not help you get less than L. The question is, how many ways to get L? To do that, you definitely need to start with L and maybe take X or maybe take modulus of X. If you take X, you always get this minimum. But if you take modulus X, you only get minimum if L was positive. So if L is at least 0, then ways minimum nu is 2 times ways minimum. But if L is less than 0, then actually ways min is just ways min as it was before. Because you cannot take absolute value to get minimum, it will be increased. Okay, now when we understand about L, let's understand about maximum. But about maximum, we would like to understand about maximum. So first of all, definitely we want to either have a modulus of R or modulus of L. Okay? One of these numbers is maximum. And also they can be equal or not equal. First case is that actually if L equals R, then actually these numbers ways min and ways max are same, and actually it's not two different ways to get L and then get the maximum, or get R and get the maximum, because L equals R. So if L equals R, then simply you need to ways max is 1 or 2 times ways max. How to decide 1 or 2? Well, 1 if R is less than 0, and 2 if R is at least 0. Yeah, because in case of 1, you definitely need to take absolute value. And if R is at least 0, then you can take or not take. And you get the same maximum number. Second case is if modulus L is equal to modulus R, but L is not R. Then ways max, there are actually plenty of ways. First of all, you can take just R. Secondly, you can take R and then take the absolute value, so 2 times. And finally, you can take minimum and then take the absolute value, so plus ways min. Okay, third case is that R is greater than L. this obviously means that r is greater than 0, because if r is less than 0, yeah, so this is r and this is L, then modulus of r cannot be greater than modulus of L if r is negative. So r is greater than 0, and this way we know that Weiss max is 2 times Weiss max before the operation, because you can take absolute value of this number r or not take. Finally, if L is greater than r, notice that you cannot get it any other way, because you cannot get it from L, and you cannot get it from intermediate values. So finally, L is greater than r. Then again, L is less than 0, of course, because 0 LR, so if L is non-negative, then it's impossible for it to be greater than R by absolute value. So in this case, you definitely want just to take the absolute value, so Weiss max prime is simply Weiss min. That's it. So this is something like DP problem with very small number of transitions. Okay, I will get this round unrated because obviously my delta will be negative. Obviously my delta will be negative. This was too slow. This was too slow. Did a lot of people have failed B? Let's look into my room. No, in my room nobody failed E. Oh, no, nobody failed B. Because in some chat they say that there is a wrong solution in B. Well, never mind. Problem D. A string problem. Question was, I'm calling the problem a question, but okay. The question was, you have a string S, and you need to divide it into several strings of form either A or not, or some string T which is chosen in advance by you. You need to find the number of such strings T that this partition is possible, if I'm not mistaken. Okay? So the number of strings T such that you can partition S into strings A and strings T, and there is at least one occurrence of string T. Okay, how to solve this problem? And string T is not just a single character A for some reason. Okay. I believe there are two cases. Yeah, there are two cases. First case is that S is simply a string of several letters A. In this case, since you want T to be a substring of this S, then T should always also be several A's. So the question is how many A's? Well, if you choose one A, it is incorrect. If you take n A's, or at least n plus 1 A's, it is also incorrect because you cannot just fit so many A's in this string S of length n. So you only can have from 2 to n A's, and actually it works. It works because you can just say that S is T, and then you apply A n minus T times. So in this case, the answer is n minus 1 if S consists only of A's. The second case is that S has not A. Good. Now I want, for some reason, I don't want T to start with A and end with A. Let's just imagine that T cannot start or end with A. Why is that? Because actually there will be a very simple criterion if it is possible to make this subdivision. So what is the criterion? Let's go through the symbols one by one. Let's go through the symbols one by one. So I start with the symbol. If it is A, then T does not start with A, so I have to take just a string A. If I have not A, then definitely it is a string T. So I check that the next T symbols are just a string T. If yes, then I continue from this symbol. If no, then I halt. And this way I go through this string and I can understand if it is possible in O of n time. So if in O of n time, I can understand if you can subdivide S in strings of T's and A's. Good. Yes? Well, I will now try to speed this up. So I'm not satisfied with O of n time. It is too slow. I want to speed up it. How to speed it up? Well, actually, notice that you can remove all A's from the beginning of your string S. So let's take our string S. Notice that if it starts from several A's, they can be removed just because, as I said, since T cannot start with A, T cannot start anywhere here because it would mess with this A, and it is not allowed. Therefore, you can just ignore this prefix of A's and assume that S starts with not A symbol. So A starts with not A symbol, example B. This means that T is actually a prefix of S. Yeah? You want T to be some prefix of S. Okay? So actually, here we know that T is not only some string, but it is a prefix of S. Let's then speed up this solution. When we see a symbol, if it is A, we skip it and go to the next one. But if it is not A, and then we need to check, is it true that we have symbols T here? But as I said, our string S starts with T, because T is the prefix of S. Therefore, you can calculate something which is called Z function. And it will say to you, is it true that if you start from here, then the common prefix of this string and the whole string S is at least of size T. If it is at least of size T, then indeed there is a copy of T here. And if the function is less than T, then there is no copy of T here. So we can check the value of the function in O of one time, and then we can just jump to this position. Unfortunately, this is still O of n time. Although we can skip T's, now we still cannot skip a lot of A's. So if there will be many A's, we just go through them one by one, and this is O of n approach. Let's also speed up A's. How to speed up A's? Well,
notice that if you see an A, you want to skip it, but you also want to skip all A's that that go beyond this one. Then you can just learn how to skip all A's. Let's make an array skip, which finds the minimum J such that J is at least I, and on the position J we have not symbol A. So that is the minimum index after our current index, which is not A. So this is our array skip. The array skip is really easy to calculate. So we will calculate it from right to left. Assume that we know the skip value for this element. Let's find it for this element. If this element is not A, then skip of I is simply I. So we just jump here, we don't need to skip anything. But if this symbol is A, then we want to skip this A. So we go here, and then we need to continue skipping A's. But actually, in this element, we already know the result of skipping all A's. So we just use this result. Therefore, skip I will be I if Si is not A, and skip of I plus 1 if Si is A. Okay? So this is how you calculate this array of skips. And actually, each time when you go through your array, if you see an A, you can skip, and actually you can always skip, because even if this is not A, then array of skips gives you the correct result of staying in the same position. So you skip all A's via this thing, and you jump one occurrence of T by this thing. So you like alternate between skipping A's and jumping one T, skipping A's and jumping one T. You skip all A's in O of one time, and you jump over T in O of one time. So the asymptotics is the number of jumps. Number of jumps, let it be M. Actually, you know that the size of string N, the size of string S, is at most the number of jumps times size of T. Because each jump is one occurrence of T. All these occurrences are not intersecting, so they should all fit into our string S. Therefore, jumps is at most, sorry, it is other way. Jumps is at most S over T. So the number of jumps is at most the size of our full string divided by the size of T. Therefore, we can make one check in O of N over T time. In the worst case scenario is still O of N if T is small. This is O of N. However, when T gets bigger, this decreases rapidly. So actually, if we solve the whole problem in O of this time, what can we do then? We can iterate over all possible prefixes. Yeah, as I said, T is a prefix of S. So we check all possible prefixes. So iterate over length of T. Then we check that, then we find the answer for this size of the prefix, and we add it to the total answer. So we get like sum of n divided by I for I from 1 to n. This is, for some reason I said that this is a SQRT decomposition, but actually it's simply n log n, because this is harmonic series. N times harmonic series of n. Great. So the question is how to solve it in O of n over modulus t time. Well, as I said, if t can only start with not a and end with not a, then it's easy. The problem is, okay, let me say, actually I never used that t does not end with a. So let's say that t can end with a, but it cannot start with a. Okay? So t cannot start with a. That's it. That's all I say. T cannot start with a. With an a. Okay? So then we can solve the problem. However, t can start with a, actually. So we also need to somehow consider these cases. So let's say that t is several a's and then t. If it's possible to partition our string s with this t, then it's also possible to partition with this t, because you just use this for a's and then write your t. Each time you need this element of partition, you write this. So if it's possible with this t, it's possible with this t. So actually for each t, yeah, initially we wanted to add 1, because it's just one more number of strings t possible. Instead of that, we need to add number of such case that a to the power k plus t is good. So we know that k equals 0 is good, but we need to check all such case. Well, let's see. We have our string s. We have somewhere, and we know where, we have somewhere occurrences of string t. Okay? The question is, how many a's we can add to the left of our t's so that it is still a correct solution. Okay? The answer is so many that here you do not move into pre-string, and that here you do not overlap with the previous t. So you want to add, you can add as many a's as you want, unless you step on the previous string or in the beginning of the string. So actually you want to find the maximum number of the maximum size of the following segment. This segment, this segment, this segment, and this segment. So you need to calculate all these segments, and you need to find the maximum length of such segment. Actually, during the contest, I did it a bit harder. In my case, t couldn't also end with a's. So actually, these intermediate a's were combination of some left a's and then some right a's, and it is hard to calculate. It's still not very hard, but I had some formulae, and here we will not have formulae. So actually what you should do in your solution, you need to go through your make the same algorithm as I said with skips and t's, but each time you skip, you memorize how many a's you have seen here. For each such segment of a's, you know its length. Then you minimize all these segments, well, except this one, because this one should be ignored. So you find the minimum length of segment. Let it be L. Then all such strings are good. T, AT, A squared T, etc. A to the power LT. So L plus 1 should be added to the answer. This is the solution. So let me quite fastly recap. You learn, well, first of all, you cut out all beginning a's from your string s, but you memorize their number, q. So your string s does not start with a. Then you learn how to jump as bunch of a's and a string t, which is a prefix of our string s. Both of things are easy. And you can therefore make a whole jump through the string s in O of n over t time. Then you also learn during these jumps the sizes of these strings of a's. You need to find the minimum of them. Let it be L. Then the answer is added L plus 1. That's it. System test. Ah, it's final standings already. But still no rating changes. Well, it's a bit sad that it did not solve this problem, H, and that it did not solve problem G. They're both nice, but I just didn't have enough time. Okay, problem E. Shuffle. We have a shuffling procedure with our trees. Procedure is as follows. You choose any vertex V. You create a new tree with V as a root. You remove V from T. And the tree is decomposed. Let me draw it like somehow. So we have some tree T, which looks like this. There is some vertex, which you choose yourself. And there are several subtrees. This is vertex V. So what is T prime? You take V as a root. Then you have several trees, T1, T2, T3, etc. T. Then you shuffle each of them and you get rooted trees. Then you add these rooted trees here. So you have T1 prime, T2 prime, etc. Tc prime. You want to maximize the number of leaves in this tree. Moreover, if the degree of V is 1, then it should also be counted towards the answer. So even the root is a leaf, it is counted as a leaf. How to solve this problem? Well, I was struggling a bit, but then I had a useful observation which solved for me the problem. Actually, so first of all, let's say that the root is not counted as an answer. So you never say that answer is a leaf. If root is not a leaf, then actually the answer equals the size of the maximum independent set. This is the answer. Why is that? I actually proved it during the contest. But if you want the repetition, I can do it fast. So to understand why is that, you need to prove this inequality and this inequality. Why answer is at least maximum independent set. Let's draw our tree and take all vertices which are in our independent set. Let's do the following. Each time when we need to choose a vertex and make the decomposition, we just choose any vertex which is not in our independent set. When we choose it, we remove it, then we do everything what is said in the explanation of this procedure. When we cannot do it if we have only one vertex and it is a part of our independent set and we cannot ignore it. In this case, it will be a leaf because it is just a tree of one vertex and it is simply attached to its parent. Yes, it is a root of its own subtree, but still it is a leaf of the whole tree. If we have at least two vertices, however, then there is an edge, and both of these vertices of this edge, they cannot be in our independent set. So at least one of them will be outside of the independent set. So always you have something to choose. Therefore, the answer will be at least maximum independent set because you can guarantee that you have this independent set. What about not greater? Well, I can prove to you that the set of all leaves in our tree will be an independent set. Why is that? Let's find any two vertices which are initially connected, but in the end they are both leaves. Let's draw any two such vertices. Let's find their LCA. Their LCA was the moment when they were separated. Yeah, because what is the procedure? This vertex V was chosen, and then this subtree was treated independently of this subtree. Yeah, so we have some subtree corresponding to this subtree. We chose some vertex, and then this vertex and this vertex got into different subtrees. That means that there is one edge and one subtree where we have this purple vertex, and some other edge and some other subtree where we have this green vertex. But this obviously means that these two vertices cannot be connected. They're not connected by an edge because they're in different subtrees. Okay? Therefore, there is just no edge between them. So they are in an independent set. So actually this is true. If you don't know how to calculate the maximum independent set, well, it is an NP hard problem, but in case of trees, it is an easy DP over subtrees. So you need to find any internet material which teaches you how to make DPs over subsets, and then the maximum independent subset of a tree is an easier exercise. But now we have a harder problem. Yeah, the second thing is if the root can be a leaf. In this case, the answer is maximum of two things. Root is a leaf and root is not a leaf. Okay? The maximum of this part is easily counted the same way as 1. So we need to calculate somehow the number of the maximum value if root should be a leaf. Okay? So root is a leaf. In this case, notice that the only way the root can be a leaf is that in the initial tree we chose a leaf and it was the vertex V. Because otherwise, if we choose not a leaf of the initial tree, then it has at least two neighbors, and then in the final tree it will also have two neighbors. So no way it is a leaf. So we need to choose a leaf and find the answer. The question is, what will be the answer? Notice that actually, if we choose a leaf, then what we do after that is we simply ignore this leaf and solve the problem for the remaining tree and for the case when the root is not a leaf. So we need to do three things. Choose some leaf, remove it and solve the problem for the remaining tree, and then attach this remaining tree. Not solve the problem for remaining tree, but solve the first problem, this one, which was there. Solve the previous problem for the remaining tree, and then add this vertex as the root, therefore increase the answer by 1. Well, actually, if you don't want to prove it, you can just do as I said, but you can prove that you always want to choose some leaf and do what I just said, so you actually never want this thing. You just always want to choose some leaf and make it a root, and reduce the problem to the previous to the previous case. The question is which leaf to choose, because our procedure is currently linear, and if we iterate over all possible leaves, it becomes n squared. To avoid that, you need to add this in your DP state. So how are the problem with... So how a problem with removed leaf and with not removed leaf are connected? So actually, you can just solve the problem for just the initial tree T, but at some moment, you are forced to not use some leaf. You just need to have some leaf which is not taken into your independent set. If you can do it, then it will be your vertex V, and you make it your root and then do everything else. So not only do you need to calculate the maximum independent set, but you also need to find the maximum independent set where you need to not take at least one leaf. Okay? Now, so the question is how to calculate the maximum independent set of over tree where there is at least one leaf not taken in this independent set. This is simply some slight more complicated dynamic programming over subtrees, but it's totally the same. So you just, for each subtree, need to calculate four things. You need to calculate its maximum independent set if you are forced to take this vertex. If take root. Maximum independent set if not take root. The third is maximum independent set if take root and forced to not take at least one leaf. So there should be at least one leaf, then you not take it. You not take at least one leaf. Not take at least one leaf. And fourth thing is the same, but if not take root and not take at least one leaf. So you have four numbers, and it's an exercise for you that if you know all quadruples of such numbers for some vertices, which are children of some parent vertex, then you can also calculate this quadruple for this vertex. So this is DP problem, DP, greedy, whatever. Good. Finally, problem F. I think I will not explain G and dash H because I'm tired, sorry. Problem F. Reconstruction. There is a hidden array of length n whose elements are integers between minus m and m. You are given an array B with characters P, S, and question. Whoa, brute force and DP? Why not greedy? All problems on Earth are greedy. So you have these characters, and you have an array, and if a character is P, then BI should be the sum of on the prefix of AIs, and if ith element is S, then BI should be the sum on the suffix of the array AI. Well, actually there is something to prove here, but I think I will not prove. I will just explain, and if you want a strict proof, you need to refer to the editorial. So this is an array S, this is an array B. This is an array A. So if we have some, sorry, A is here. So if some element of S is character S, then B, the corresponding element of B, is the sum on this suffix. If some element of s is p, then the corresponding element is the sum on the prefix. And you need to replace all question marks in s with correct letters and find the number of ways to do it. And you know that all numbers here are between minus m and m. So intuitively, you just want to take all pairs of consecutive letters and check that they don't contradict each other. First of all, if we have two p's in a row, what do we want to say? We want to say that this p is the sum of this prefix, and this p is the sum of this prefix. Their difference is just this element. Their difference is just this element. And so we want, so if this is I and this is I plus 1, if we want it to be I plus 1 minus bi to be at most m in difference, okay? Sorry. So what I want to say is that if you have already chosen a correct way to, I think, it's hard to explain actually. Well, okay, never mind. All I want to say is that you want this inequality. And actually this inequality holds if B is the correct array, which if B is really the sums of the elements of A, then this inequality holds if and only if AI is between minus m and m. Likewise, if you have two s in a row, then this s is the sum of this array and this s is the sum of this array. So you want this element to be between minus m and m. Let's go on. What about ps? So p is the sum of this prefix and s is the sum of this suffix. So in total, they are just the whole array. Yeah, in total, it's just the whole array. So what you really want is that if you have p and s in a row, then you want that s bi plus bi plus 1 is simply sum of all array. Finally, sp, in sp, s is the sum of this array, and p is the sum of this array. So you actually want bi plus bi plus 1 to be not very far from sigma. That is, the difference between this and sigma should be at most 2m. Yeah, because it's sum of these two elements. Good. We have 4 things. How to check them? Actually, it's not very easy because while we can check SS and we can check PP, it's just check that some element is at most, some difference is at most m. We cannot check this one because we don't know sigma. The key observation is notice that here n is at most 2000, and therefore you can do it in n squared time. Let's just iterate over all possible sums. So let's assume that we know the sum. Then we can actually check this condition because we know the sum. And we can check this condition because we know the sum. How to iterate over all possible sums? I will explain it a bit later. I will explain it almost now. First things I want to say is that actually let's extend our array B one position to the left and one position to the right and add there 2 zeros. Here we will write P and here we will write S. This makes sense because this P means that this element 0 should be the sum of everything to the left of this position. But to the left of this position there are no elements of A because A starts here. So this is indeed 0, this is indeed the sum of this array. Likewise, this 0 should be the sum of this part. So it's the same thing. Why did I do that? Because of that, you can ensure that your string starts with P and ends with S. Okay? And since it starts with P and ends with S, at some moment there will definitely be P, S substring. Yeah? How to prove that? Let's find the rightmost P in this string. This is the rightmost P in the string. This next symbol, it exists because the rightmost symbol here is S, so this is not the rightmost symbol. And it cannot be P because we have taken the rightmost P. Therefore, it is S, and since it is S, we have found the PS substring. Okay? Okay, we have found the PS substring. Therefore, as I said, the sum of these two elements should be sigma, should be the sum of all elements in A. Therefore, if we iterate over all pairs of consecutive numbers in B and add them up, there will be like n+1 variance on what the sum can be. And we just iterate over all of them and consider them one by one. And actually in each of them, the choices which we need to make here are different simply because you cannot have, with two different choices of sigma, you cannot have PS on the same position. If you have two arrays with PS on the same position, then the sum of array is also the same in both of these options. Okay, now we can say that we know the sigma. We can make all these checks. How to solve the problem then? Let's just have a DP. We go one by one through all the symbols, and for each prefix, we answer two questions. What is the number of ways to fill all question marks here, such that there is no contradiction so far, and this symbol is S? And how many ways of do that if this symbol is P? Then there are 4 transitions. From this S to this S, and from this S to this P, and from this P to this S, and from this P to this P. So there are 4 options: SS, SP, PS, PP. For each of them, I have already told you what you need to check. And also we need to check, for example, if there is question mark, then all these transitions are allowed. But if, for example, there is symbol S, then these transitions are ignored because you cannot have P on the position of where it is already known to be an S. Finally, what I haven't told you yet. Let me think. I haven't told you something yet. Some intuitive observations which will explain you why it is a correct solution. Well, this is a correct solution. However, I have checked some properties which I have not proved that they are sufficient. I have checked that for any 2 consecutive letters, there is nothing wrong with them. That is, there is no contradiction for them having their values. What I need to explain is that actually there will be no contradiction at all. And for that, I will need to give you some explanations. Well, actually, what could be the problem? It could be a problem if some things lead to some number that it has to be equal to 1. For example, a7 should be equal to 1. But some other considerations say that this number should be equal to 2. And since the same number cannot be 1 and 2, then we have a contradiction. Well, let's see which numbers are touched by some by some combinations of letters. For example, SS. SS simply says that these elements should have some concrete value. PP says that these elements should have some concrete value. PS does not tell anything, does not tell us anything about any particular value. It just says something about the sum. And since we know the sum, it just does not say anything at all. Finally, SP says that the difference between the sum and sum of two values should be at most 2m. Well, if we say that it should be some number k, then the sum of these two elements ai and ai plus 1 should be this number k. The sum of these two elements is known. So can it be that, for example, this rightmost p is same for several operations? Actually, it is not possible. This rightmost p has a p to the left of it. So for each pp constraint, all these p's are different. But what about pp and sp? Actually, they are also different, because for this p to the left of it, there is s. And for this p to the left of it, there is p. So this position cannot be the same as this position. Likewise, ss and sp have different s's here, so these elements are also different. If you write it carefully, you will see that actually each combination of two consecutive letters only once restricts our array A, and all elements which are touched by these restrictions, they are pairwise different. So if we fix, so we just need to somehow find all values of which values which are fixed. And for the rest of array, you simply want, how to explain? Okay, let's just explain that each number ai will be touched exactly once, but by our restrictions. Let's take some number ai. For the sake of, without loss of generality, let's say that it is p. Let's look what is to the left of this p. If to the left of this p is nothingness, then actually this is the leftmost p auxiliary which we added here, and this means that there is no ai at all corresponding to this p. If there is p here, then as I said, only this and only this constraint explains us what the number should be here. And if there is s here, then sp and only sp explains us what should be here. So basically, we can calculate number ai. And for s, it's the same. We can just calculate all the numbers, and the remaining thing will be to explain why the sum is correct. So why we have the correct sum. And it can be actually proved. It can be proved somehow. You can look in the editorial why the sum will be correct. Also, what I just wanted to say is that there will be no element AI which is restricted twice by our restrictions. So each element will be restricted only once. That's the first step in the proof of why my condition is not only necessary but is sufficient as well. So I think that's it. This was not the worst contest, but something strange happened for me, and I wrote it badly. It happens. Thank you for watching.